But there's 3 different manipulatives I want to try to get through, so in an hour that's cutting it close. So if people filter in, they can filter in. Thanks for coming. It's really nice to have you guys here so you can see what the students are doing in the classroom, and then you can, you guys have your own sets, you can pull them out if necessary, so that's really helpful. We're going to start with what are called the rainbow fraction circles. So that's going to be this one, kind of look like pieces of a pie. So if you want to get those out. And if you don't have enough in your little bin at your desk, there's 2 more bins right there. So if everybody wants their own bags, you can take from those bins if you want. I just wasn't sure how many people were going to be here.
So who's going to get one? We're good now, huh?
Did you not try to keep her deal?
Yeah. We went a long time ago.
Shut the door. I don't want to. Should I shut your pie?
Yes, and he's cut himself back this semester. He used to stay till 2 in the morning.
Okay, so the packet that I have for you guys is kind of a mixture of different activities from different parts of the module. So it's not necessarily one, like the student wouldn't get this whole packet at a time. I just kind of took pages from different activities, the pages where we use the manipulatives. So like I said, it's not like you would do this whole packet in one day. This is from different days throughout the module that you have. I just kind of stapled them together so we didn't have all these loose papers. Okay, so in the very beginning of the module, what we do is we like to introduce the students to the different types of manipulatives they're going to see throughout the next 5 weeks. So that's what this first activity is. It's just kind of getting them used to the different manipulatives. So the fraction circles, then we'll look at the Cuisenaire rods, and we'll look at the pattern box. So you can see the first one talks about the fraction circles. Right. So you can see the first one talks about the fraction circles, and really all we're doing is we're just trying to get the students to understand what each different color piece represents. Now, I know that there is the little paint reference sheet in there, but that's more for so like when they're done, they know how many go back in their bag. But it's really powerful to have the students take all the colored pieces and put them together to make one whole. So I think that's really powerful instead of them just looking on the pink sheet. It's really powerful for them to put it all together to make one whole. So for instance, if there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, if it takes 10 purple pieces to make a whole, then they can understand that one purple then would represent the fraction 1/10. So why don't you just take, I don't know, a minute or 2 to go ahead and figure out what each color represents. And like I said, I know you have the pink sheet there, but try to do it from the point of view as if you were a student and we wanted you to be making the complete circles, just so you can see it through their eyes.
So like right now,
And if you might be short,
since we're doing it,
they never seem
yeah,
to get
we get
back
on the screen.
together fully when the students are done with them.
Move it down.
Yeah, over
The blacks are, is it 12
there,
blacks?
like that. You just want to like get it centered.
And this is usually, and I mean, sometimes the students are a little apprehensive to do this. They don't want to dive in like you guys are right now. You guys are eating it up right now, and I love it. You would be my model class. But you know, you get students there who won't even open their bag. They just sit there with their arms crossed. So you got to kind of prod them a little bit. I always tell students they're not toys. I tell them they're tools for learning and that they're not toys. We're not just playing with toys. Because I think at first they kind of think it's a little juvenile when they see all these bright colors and all these plastic pieces.
What are they doing, importing something from kindergarten? I'm a college student.
Pretty much, yeah, that's what we get, you know. And then I, in a nice way, have the conversation with them. Well, maybe if you would have had these in elementary school, you
You would, right.
not necessarily you wouldn't be here, but you might have, you know, had a better grasp on fractions the first time around. And then you hear a lot of students say, oh my gosh, I never thought of it that way, and so they appreciate it after a while.
Oh, okay.
Those are the
Blue. You don't list all the colors on the question.
Are they not all there? I think it's just to try to get them used to it.
That'll be eight.
You didn't put green and blue down.
A teacher set that he'll keep up with.
Easier to get.
Oh, right, she walks in, ordered them yesterday, so they should be in your.
The bins or,
Mhm.
yeah.
1, 2.
Okay. So after they do that, so again, that was just to get them used to what these fraction circles are. Okay, then we would kind of put those aside, and then we would have them look at something else that we would use to describe fractions. And now this next one is really just on the paper. This is just a rectangle. We're going to get to the Cuisinart rods in a minute, but you're going to see throughout the module, you'll see this a lot where it says use blank to represent the unit, and we literally want them to draw a rectangle to represent the unit. So the idea of this first lesson is just for the students to understand that the unit can take any shape or form. Like my unit could be a complete circle, and if my unit is a complete circle, then my pink is equal to 1/2. But we also want them to understand maybe my unit is the pink circle. If I define my unit as the pink circle, then the yellow piece is 1/2. So we want them to understand that the unit doesn't necessarily always have to be a complete circle. The unit can be whatever you define the unit to be, and then you define other shapes in terms of that. So then this next one would get them to understand that maybe this rectangle could be the unit. Okay? So let's jump down to part B. I'm not going to do every single one with you, but I do want you to get an idea of the language that we use in this module. So it says use the unit to draw the fraction 3/5. So here's their unit. Okay? And so then we would talk about 3/5. And now it says write a sentence to describe the meaning of 3/5. The idea of this module is what we don't want the students to say is 3 out of 5. We kind of want them to get away from looking at it as you have 5 total and you're taking 3 of that. We want it to be more like an area comparison of like how much of the unit do you have. So instead of saying like 3 out of 5, like 3 out of 5 boys in a class, we want them to realize what that actually represents in terms of a picture. So you would split it up into 5 equal pieces, and then you would color in 3 of them. So if that's our unit, then we just use the unit to draw the fraction 3/5. Now the sentence we want them to get out of this is that 3/5 is 3 copies of 1/5 of the unit. And up here, in the one where it was 1/4, we would want them to explain, okay, we took the unit and we divided it up into 4 equal pieces. 1/4 represents one of those pieces. So they understand what the 1/4 means. So now down here, when our numerator is not 1 anymore, they understand that the 1/5 would be 1 of 5 equal pieces, and then 3/5 would be 3 copies of that. So that word copies of is going to happen a lot. We saw it in module 1 with multiplication. We're seeing it again with the multiplication with fractions. So like for instance, later, when we get to fraction multiplication, and we do a problem like this, say we're going to do 1/2 times 1/4, we want them to understand that's half of a copy of 1/4, okay? Or even when we do a whole number, say we do 2 times 1/5, we want them to understand that's 2 copies of 1/5. And then from these manipulatives, they have an idea in their head of what 1/5 looks like. So 2 times 1/5, oh, that just means I have 2 of those pieces put together. So like the 1/5, which color is 5th on here? The green, for instance, now that they've worked with the rainbow fraction circles, if they know what 1/5 looks like, now they know, well, 2 times 1/5 would just be 2/5, 2 copies of that 1/5. So that's why that word copies of is so important, because it leads to so many things as we get closer and closer to the end of the module. Now let's just do one with the improper fraction. So it says use the unit to draw the fraction 4/3. And this is the reason why we don't want the students to only think of a fraction as something out of something, because then when you throw them in improper, well, how do you have 4 out of 3? That doesn't really make sense to them. So we want them to understand that is 4 copies of 1/3 of the unit. So a third of the unit would be the unit divided up into 3 equal pieces. Well, how do we get 4 of those? Well, we've got to go and introduce another unit. So 4 copies would be the 1 whole plus an extra 1/3. And then that helps us later on lead to the idea of a mixed number. So it's not necessarily 4 out of 3. It means we have the whole entire unit plus another third of the unit added on to it. So 4 copies of 1/3 of the unit. Okay. Kim, did you have anything you wanted to add that you do differently when you do it? I didn't know if you had any other insight. Okay, all right. Okay, then the Cuisinart. These are fun. These are intimidating to both teachers and students at first, I believe. But I really think once you get that initial intimidation out of the way, they're really powerful. And hopefully we don't run out of time because these are really powerful when we do division of fractions. They're very, very helpful for division of fractions. Okay, so now we're going to the Cuisinart. And we're going to go back and forth to the different manipulatives, so you don't necessarily have to put them away if you don't want to. You can kind of put them to the side if you want. We're going to use the fraction circles again.
Yeah.
All right, so it says make a train orange and brown. It looks like the brown didn't come through very well in the color copy. So there's our orange and our brown. So when it says make a train, that just means you butt them up end to end to each other. So, so when it says make a train with the orange and brown, that's what we're looking at right there. You're putting an orange right up next to a brown. All right, how we doing? We got our trains? We good on our trains? Okay, come along here. Okay, so we got our orange and brown. And again, now notice how it says this is our unit. So the idea is to let the students realize that, like I said, the unit doesn't have to be the traditional full circle. The unit doesn't have to be just one bar. Why can't the unit be 2 different colored bars put together? The unit can be whatever you make it, and then all the different colors then have a value based on what you decide the unit is. So now they're saying the blue piece would be what fractional value. So if you get a blue piece out, the idea is we want the students to figure out, okay, well, how many blue pieces does it take to fill up the entire unit? So if it takes me very good. Very good. So what do you think that means? If it takes 2 blue pieces, what fractional value is 1 blue piece? 1/2. Right? So one of those blues would be half of the unit. Okay? So then the dark green, let's try that one. So then we have them see how many dark greens it takes to make up the unit.
This is very convenient that it's working out as multiples.
It is, isn't it? What do we do when it doesn't? I can't wait till that happens.
Take out the saw and cut it in.
So now it takes 3 of the dark greens, so that means 1 dark green would now be 1/3 of the unit. Let's see if any of these don't work. Let's try the light green. Does the light green work?
Purple does it.
Purple. But I mean on here, on our paper, I was wondering if any of them don't work.
No, I think they all work.
Okay,
Yeah.
we'll do one that doesn't work.
Your sense of perfection.
All right, so the light green, obviously it takes 6 of them, so the light green represents 1/6. Okay, now let's try one though that doesn't work. Let's try even though it's not on the sheet, just so you guys see what happens when something doesn't fit. Okay, so let's try to match the purple up. So we see that our purple overlaps. Okay, so if we really, I mean, this could also be a way, and when we do the lesson on equivalent fractions, we actually use the circles, we don't use these, but this could be another way to introduce or show students what equivalent fractions are. So if our purple doesn't work, and we need to figure out what part of the unit our purple is, what do you think we could do? Anyone have any ideas?
Add white.
Supplement it with a white, maybe, or
Okay.
or there's maybe just-
Did we figure out what the whites are worth
Other
yet?
orange.
118.
Okay, so let's kind of go back to the light green. If the light green is 1/6,
Mhm.
and it takes me 3 whites to make up a light green, 3 times 6 is 18. So now we know that the white piece is 1/18. So they really don't have to line up all 18 white cubes to figure that out. They could say, well, there's going to be 3 in each green one, so that's a total of 18. Okay, so then let's see here. Let's see what we can do. Let's get our whites.
My ones are a little short.
You're-
It's close enough.
Oh, you
For the
think
purple,
yours
you
are a
mean?
different
For the
size?
green.
Oh, for the green?
Yeah, it's a,
No, he's standing them up. You're not supposed to stand them up. Okay, so if I could get 4 of those whites to take up the space of one of those purples, what fraction would the purple bar represent? So if it takes 4 of these whites to cover one of those purples, 4/18ths, okay? And then we would, then we could talk about, and at this point, we wouldn't have learned how to simplify yet or equivalent fractions, but it's still something that could lead into it. So then we could say the purple was 4/18ths, or we could say 2/9. Is the red a ninth? Does red come out to be 1/9? Yeah. So then when you say, oh, okay, 4/18ths, well, that's the same as 2/9 if the red is 1/9. Then 4/18ths, we could show them is equal to 2/9, because 4 of those whites are equal to 2 of those reds. And then that would lead into simplifying fractions, how 4/18ths becomes 2/9. What do you think? You like the rods? Not sure yet?
I think they're great, but there's a couple times I got thrown off because they're not cut very precisely. 'Cause
You need to send Ben to the wood shop with
The error
our.
gets multiplied.
Rachel actually does have one that's like inches too short.
The purple?
So I told her to throw it out.
Paint it.
Yeah.
Oh, wow, that is.
So that's
Maybe that was
more than-
supposed to be a, is that color supposed to be a, like,
Maybe green. Oh, that's it.
it's painted the wrong color.
Let's throw it away.
Yeah, let's take that one out. No, seriously.
She gets the prize.
You do?
Yeah. The almond in the ice cream or whatever that Danish thing is.
Oh, so right here, so part D, are there other ways to represent the fraction 4/9? Let's see, did I jump ahead and didn't answer the question? Yeah, so it's kind of then going through, describe how you can represent the fraction 4/9 using rods that are all the same color. So you could say 4 whites. No, I'm sorry. Oh, 4/9 would be 4 reds. 1, 2. So I'm on part C. So 4/9 would be 4 reds. Are there other ways to represent it besides your solution in part B? So instead of 4 reds, what might we be able to do? 8 whites. We could say 8 whites. Okay, so again, it's leading them to the idea of equivalent fractions. Okay. Now it says using the same color rods, draw a representation of 7/6. So if I want to do 7/6, what do I need? 7 of what color? 7 light green. So now this is introducing them to the idea that you can go beyond one whole. So that would be 7 light green. And then if we butt it up to our unit, what do you notice about the length of your representation compared to the original unit? Well, it's longer than the original unit. Why must it be true? Because now we have 7 copies of 1/6, so we have more than the original unit. We have the original unit plus 1/6 more. So that would be like an example of what they could write for part E. Okay, questions on the rods before we move on to the next one? What do you guys think about the rods? Do you like them? Do you think, how many of you raise your hand if you've never used the rods before? Just out of curiosity to see who's never seen them before. Okay, cool. And in your first experience, do you think they're cool? Show the students the relationships. Again, thinking of fractions in terms of area instead of in terms of 1 out of 4 really helps the students, like I said, because then what happens when they have 4 out of 3? Then they're thrown for a loop. They have no idea what that means, 4 out of 3. They don't understand. It means you have 4 copies of 1/3, and now you're bigger than the unit. Okay? All right, the pattern blocks. All right, let's go ahead and get these out. I really like this activity as well because, again, it shows the student that the unit can take on any shape. The unit doesn't have to be, the unit doesn't have to be a traditional full circle, or doesn't even necessarily have to be only one solid shape. It could be more than one shape together.
I was gonna share with you.
Oh.
In this box. Okay, got it.
Yeah.
Oh, I don't know, I evidently were short on several pages.
Okay, so again, they're changing up what the unit is. So in this table, on the left column, the unit will change. But then in terms of whatever the unit is, we're going to see how the fractional value of each color changes. So if my unit is, we call this the hexagon. If my unit is just one plain hexagon, okay, then the yellow one represents one whole. Okay, so now what does the red represent? So then we get our red, and we say, okay, well, it takes 2 reds to cover that one unit. So the red is now 1/2. Okay, let's figure out what the blues are. These are the fun ones. You gotta mix them or fit in there. Okay, so it takes me 3 blues to cover up my unit. So blue is 1/3. Now, let's see if we can figure out what the green, this is what I would say to the students. Let's see if we could figure out what the green is without actually having to cover it all in green. So if I take the green, let's say I put it on top of my blues, well, look at that. 2 greens make up one of those blues. So how many greens would I need to cover the whole thing? 2 more, so I would need a total of 6. So that's trying to get them to start imagining it and start visualizing it, that you would need 6 copies of that green rectangle to, or not rectangle, of that green triangle to make up your unit. So each green would be 1/6. Now we're changing the unit. Now the unit is 3 hexes put together. So you guys might need to combine your bags if you want to actually build it. Okay, so now, if that is my unit, what does that do to one of my yellow pieces now? What is my yellow piece now worth? 1/3. Okay, so again, the idea is to show the student that this isn't always one whole. It depends on what you're identifying as your unit. And then that even helps them way later on when we do percentages and things like that. You know, when we're trying to say, you know, when we change our base or when we go over 100% or things like that, it can help them see that your base doesn't always have to be the same exact thing. It can change. It's not always going to be 100%. We can go over 100% or things like that. So it's nice to kind of get them to think backwards as to, okay, this used to be one whole, now it's only 1/3. So then the red one, so if there's 2 here, I would need 2 more. Now the red takes on the 1/6 role. Right? And then can we imagine what our blue would take on? What fraction would our blue now represent? 1/9. Because it now takes me 3, and I would need 3, 6, 9. So now what would our green take on? What would our green now be? 1/18. is nice because now we go over a whole. So now if our unit is just the red one, and we look at our yellow one, right? What does our yellow one now become if our unit is just the red one? What would our yellow one be? 2, right? We would go over a whole, because now we have 2 of those. And then the red one would just be the 1 unit. And this one's fun. How would I figure out what the blue is? It doesn't cover the whole red, but if I add another blue, I'm too much. So what do I have to do to figure out what the blue is? I need a green, right? I see that I can fill in that missing spot with a green. So to figure out what that blue is, oh, it's 2 greens. So that would be 2/3. Because it takes me 3 greens to cover up the red, 2 copies of those, so 2 copies of 1/3 cover up the blue. So then the green would now be the 1/3. So again, we're really not doing any operations here. We're not even simplifying, really. We're just getting them to understand that the unit can change. And that fraction is an area, like the fractional value is an area instead of 1 out of 9, you know? It's more of how much space does it take up of the shape. Okay? I mean, they can still kind of think of it as 1 out of 9 because this blue would be 1 out of 9 blues. But again, thinking about it in terms of area really helps them. You guys laughing?
Oh, no, he thinks he's back in grade school.
These are not toys, Jacob. Now, these ones, we won't go through all these, but these ones really start to teach them that you're going to have to exchange colors, which leads them to needing a common denominator later on. So now, if my unit is the hexagon plus the trapezoid, and I want to know what the red one is, well, I got to exchange my yellow one for 2 reds. So the red would be 1/3, and the yellow would now be 2 copies of that. The yellow would now be 2/3. So that's just teaching them to start exchanging for colors, and you'll see that when we start adding and subtracting the fractions, how we have to do that. All right, questions on the pattern blocks before they move on? All right, okay, let's see. Okay, so on the next one, we're going to go back to the rainbow fraction circles, and now we're going to start to talk about equivalent fractions. Okay, so it says use your fraction circles to help name 2 equivalent fractions to the 3 fractions listed below. So 1/3. So now that they've been introduced, so like I said, this wouldn't all be in one day. This would be days later. They were introduced to them, now we're coming back to them. So now, say we want 1/3. So they would get out their orange, right? Okay, but we want to name 2 other pieces that would be equal to that. So again, if you're thinking of fractions in terms of area, you want to cover that whole space with different colors. Okay, so I mean, it's kind of cool. Sometimes it's actually kind of cool when they don't catch on right away. Like if they, you know, some of them right away they'll say, oh, just multiply by 2, 2, 6. You know, 2 on top, 2 on the bottom. But it's kind of cool when they don't catch on because then you really see them. They'll take like a 1/4 and they'll be like, oh no, that doesn't fit. You know, and then later we can talk about, well, why didn't the 1/4 fit? Oh, because 3 times the whole number is not going to get me to 4. Like we talk about that when we start creating more equivalent fractions. So they play with them until they finally find a color that will work. Okay, so I can get 2 teals. Well, each teal is 1/6. So 1/3 could also be 2 copies of 1/6 or 2/6. And again, you would keep saying 2 copies of. If it takes me 2 teals, that means I have 2 copies of 1/6. So I have 2/6. Or, let's see what else, you know. You know, say they try a black, and are the blacks? The blacks are 12. Let's say they try the purple first. Say they try to fit the purple in there. And the purple doesn't fit. And if you put one more purple, you're over. So then again, later you can have a conversation, oh, that's because the purple was 1/10. I can't turn 6 into 10 by just multiplying by a whole number, so it's not gonna be a whole number of pieces. I would need a portion of another piece. So that didn't work. So then you try the blacks, and you would see that you need 4 blacks, which would be 4 copies of 1/12. Okay. So then that just kind of helps them see the idea of equivalent fractions. And then it keeps going on. It teaches them what then the inequality statement, how to fill that in. What patterns do you see? So then they talk about how they're all multiples of 3. The denominators are multiples of 3. And then again, we can go back up and talk about, well, that's why the black piece or the purple piece would work, because the purple was a 10. 10 isn't a multiple of 3. So we talk about why that some shapes work and some shapes don't work. Now here you can see we try to have them do it without the circles, without the pieces. Can you do it now just talking about the multiples that we talked about? Okay. And then it says name one and then create one more without using your fraction circle. So again, we're trying to get them to use the pieces and then kind of take them away so they don't have to. And now these are nice because now these get simplified. So 8/10, you'd have 8 of the purples and then you would try to use less shapes to color it, to cover it. So like if you have 8 of the purples, take 8 of them out. I'm just jumping to part B down here. I don't know why. There's 6. 7, 8. Because they might say, oh, I don't have any pieces that are small enough. There's no more smaller pieces that work. Well, why do they necessarily have to be smaller pieces, right? They could be bigger pieces. So they would play around with it. I know it's going to be fifths, because I know that, but they would play around with it, and they would say, oh, well, right, wrong, this is 1, 2, 3, 4, 5, 6, 7, 8.
Is this black?
These are purples, right around 1? No, 8, 10, right?
Purples or 10s, yeah.
Oh, I was using teal or 6, sorry. I should have grabbed the green or the 5th. See, I'm a student, and I'd be like, wait a minute, it doesn't work. So they would say, oh, okay, maybe it could be a bigger piece. So you say, oh, 4/5. So now we're talking about simplifying the fractions. And I always say to the students, think of simplifying fractions as using less pieces. You want to use the least amount of pieces to cover your shape. That's how you're simplified, okay? So I've got 4/5. Can I use any, are there any bigger pieces? Like, could I cover it with the oranges? No. So the 4/5 is the least amount of pieces I could use to cover that area. So I'm as simplified as possible. So that's how I kind of explain to them 4/5. And then later we talk about, well, because there's no common factors, it's simplified. You don't have, you have the least amount of pieces, you have the least amount of factors. You don't want to have any common factors. And then right here it leads into that. Which ones are simplified? How do you know? Because this took the least amount of pieces to create that area. Questions on it? Okay. Which ones are your favorites so far?
The circles.
The circles?
They're cut most accurately.
Ben, we're going to get you a new job in the factory that produces these. Quality control.
Speaking of quality control, we support the faculty, so I keep hearing you say, use the word copies.
Yes.
Could you explain how important is that to the faculty, that the tutors pick up the same language?
It is because, like I said, the students are going to hear it in Module 1 all the way through Module 3, and it's kind of like the culmination in Module 3 when we start doing division. For instance, let's just do your basic 4 divided by 1/2. Why is that 8? Students don't understand why that's 8. Why that's not 2? Why isn't that 2? That's 2. I'm taking 4 and I'm cutting it in half. That's 2. No, you're not taking 4 and cutting it in half. And so then you go back to whole numbers. Okay, well, what's this? Oh, well, that's 4. Why is that 4? Because there's 4 copies of 3 in 12. Okay, so why is this 8? Because there's 8 copies of 1/2 in the number 4. And then you can draw, you might not have the circles out at this point, but you could say, remember, here's our 4, there's a half, 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 1, 2, 3, 4, 5, 6, 7, 8. So the copies of is really powerful, especially when then we get to something like this. 2/3 divided by 1/6. Now they're like, phew, I have no idea what's going on. They forget what division means when they see this. They want a rule. They want to invert and multiply. They don't understand what the heck they're doing. So you're saying, how many copies of 1/6 are in 2/3? So then you can, at this point, you can get the shapes out. So orange was a 1/3, right? So how many copies of 1/6 are in 2/3? So there's 2/3. There's 2/3. 6 were teal. So how many teals does that take? 1, 2, 3, 4. Because the students don't understand why 2/3 divided by 1/6 is 4. They're like, what the heck? How? Why? Why is it a whole number? What's going on? And even when they learn to invert and multiply, they still don't understand why it's 4. They don't know what's going on. They just know someone told them to change and flip some stuff, So I think the copies of is really powerful. Like, I get kind of nerdy when I think about it, because I never used these words before I learned all this module stuff. I taught OA2 for years. I never used copies of. But I feel like and I would use the idea, I would still draw this picture for my students, and I would still do this, and I would be like, oh, because 4 times 3 is 12, 8 times 1/2 is 4, and they're still like, what? What's going on? I just really think once I learned the term, I don't know, Kim, if you agree or not, once I learned how to use copies of, I was like, it just makes so much sense. It really helps them understand that they're focusing on the concept of the operation here. They're not just doing a procedure, they're actually saying, how many copies of 1/6 will fit into 2/3? Instead of just, oh, I see the division sign, so I flip and I multiply. Because then they start flipping the first fraction, and they're like, well, they don't remember what to flip, they just want a rule, but they don't understand what's going on. So I think copies of is really helpful for them. And then they can understand why the answer is 4. Because 1/6 is smaller than 1/3, and if you have 2 copies of a 1/3, you're going to need more shapes to fill it up. Does that make sense?
Yes, thank you. So we need to borrow this language.
If
we haven't already.
Yeah, your OA students, hopefully they'll be saying it when they're coming in, hopefully for help, or they'll at least have it on their paper and they'll ask you, what did my teacher mean, But, okay, the next one I want to look at, and this was another one that threw me for a loop when I first started learning the modules, curriculum. When you compare fractions, we would all just get a common denominator. Get a common denominator to compare fractions. I never in a million years would have thought to get a common numerator, would you? No, but that's a completely valid way to do it, okay? So this piece of paper here, this is more like a closure activity that you might do at the end of the lesson, but I stuck it in here so I can kind of fast forward and show you what we would have been working towards in that lesson. So it says, use the space below to write a general rule for comparing fractions with equal numerators. You must provide a specific example using a drawing. So we're always used to comparing fractions, like if I wanted to ask you, okay, what's bigger, 2/5 or 4/15? You would say, okay, multiply by 3/3, that's 6 out of 15, that's 4 out of 15, okay, 2/5 is obviously bigger. No one ever would think to get common numerators, and I think the common numerators thing is really powerful because then it actually makes them think about what changes when your denominator changes, what changes about your shape when your denominator changes. So as your denominator gets bigger, like from a 1/2 to a 1/3 to a 1/4, as your denominator is getting bigger, your shape's actually getting smaller because it's only one copy of something divided into 4 equal pieces versus it only divided into 2 equal pieces. So for the equal numerators, for instance, let's use the shapes that I want to use here. I just want to make it nice and easy, so. Okay, so let's just do 3/4 and 1% is not so obvious, but, oh well. Let's just do 3/4 and 2/6, okay? I mean, this is, I'm just trying to come up with one off the fly, but it's kind of obvious, you know, but maybe to the students, it's not as obvious. So say I want to compare those, and I want to know which one's greater than, or I want to know which one is less than, okay? So with equal numerators, so now what I can do is, if I want, I can multiply this by 3/3, I can multiply this by 2/2, that will give me 6/8, that will give me, oh shoot, I don't have an 18. I should have had a problem to come up with anyways. But, here, let me, I don't like that one. I don't have an 18. Let's do 3/4, here, let's do 3/4 and 2/5. And this is a good one because students always think, I'm gonna do 4/5. I'm trying to get one that busts their myths about fractions. Because usually they're like, oh, well, this is only 1 away. They always think like, oh, well, this is only 1 away, this is 3 away, so this one's bigger. Like that's their reasoning. Well, now what if this is 1 away and this is 1 away? What do you do now, okay? Okay, so if we get a common numerator, if I multiply this by 3/3, I still don't have a 15. Oh, well. And if I multiply this by 4/4, 12/16 and 12/15, that's okay, I don't have the shape. But then you would ask yourself, okay, what would a 16th look like? You have your unit. What would a 15th look like? You have your unit. So imagine this unit divided into 16 equal pieces, this unit divided into 15 equal pieces. Well, which one of those pieces would be bigger? The 15th? Would 1/15 be bigger, or would 1/16 be bigger? So 1/15 would be bigger. So if I have 12 of these pieces versus 12 of these pieces, which one is bigger? The 12/15ths or the 12/16ths? Well, the 12/15ths, because I have 12 bigger pieces. Over here, I have 12 smaller pieces. So that would make the 4/5 bigger. And it's not that using equal numerators is better or worse than equal denominators. It's just another way to do it. It's just another way to think about it. I'm sorry, I should have had an example prepared that I would have worked out with the shapes. But again, if I had the pieces, I would show them. But if I could get it to work out with the smaller pieces, I would just say which one's bigger. Oh, I'd rather have 12 of these than 12 of these if I want more. Kind of thing. Or I always say pizza. You know, if you're really hungry, would you rather split a pizza with 15 people or with 16 people? Oh, well, at least here I get a little bit of a bigger piece instead of splitting it with 16 people. All right. Okay. So we have addition, subtraction, and then division. Kim, I only have time to do one. What do you think I should do? Division. Or should I try to do a quick one of each?
I would.
Try to do a quick one of each? Okay. All right, let's. Okay. So I'm just going to do a basic with the addition for you. So now we're back to the pattern blocks, the foam ones. So it says, for each of the following operations, represent the answer using a single color. So it's saying, the first one, what if I had a yellow plus 1 red? Okay, so a yellow plus 1 red is this. And I said, but I want to know what that is in all one color. Okay. Well, if I want to know what that is in all one color, 1 yellow plus 1 red, is there a fish? 1 yellow plus 1 red would be 3 reds, okay? I'm gonna go quickly, but you get the idea. So the idea is, let's do one more. Let's do a yellow plus a blue. So a yellow plus a blue. Okay, well if I want that all in one color, I gotta turn my yellow into blue. Okay, so now that would be 4 blues. So what we're building up to here is the idea that to add fractions, you need the same color, which we later say, or to give an answer to add fractions, you need your answer in terms of one color. That later teaches the students that's why you need a common denominator, because you need to be talking about the same shape, okay? So then, let's just say, here, I'm just gonna skip ahead really quick. let's say the yellow equals the unit. All right, and let's say I want to do 1/2 plus 2/3. So this would, obviously you would do more scaffolding for the student. I'm just going a little bit quicker because we're running out of time. So I want to do 1/2 plus 2/3. So if the yellow is a unit, my red is a half, and my 2/3 would be 2 blues. Okay, well, I want to add those together. Well, what the heck, I don't know, what do I call that? You know, I don't know what that is. I don't know what to call it. It's not a yellow, it's more than a yellow. What do I call it? 1 red and 2 blues? No, I need all one color. Okay, I got to trade. If I use the greens, 2 greens here, 2 greens here, and then I need 3 greens for that red. Okay, and my greens were 1/6, so I have 1, 2, 3, 4, 5, 6, 7 greens, so that comes out to be 7/6. And then we talked about how we had to trade. Well, I had to trade my red 1/2 for 3 of the greens, so 3 copies of 1/6, and I had to trade my 2 blues for 4 of the greens, so 4 copies of 1/6 to figure out that it's 7/6. So the idea of trading colors and turning them all into the same color teaches the student we need to turn them all into the same denominator. And then again, clearly, you can see you're not just doing 1 plus 2 and 2 plus 3 straight across. You just walk in thinking that's what you're supposed to do. So, and then we talk about, okay, well, how do I know to go to 6? How do I know? You know, so then there would be a least common multiple activity in between. Before this lesson, they would have already learned how to find the least common multiple. So we would talk about how the color is a metaphor for the least common multiple.
If a student already understands like the conversion factor between them, is it all right if like we jump ahead and into like multiplying top and bottom to get a solution?
Yeah,
Or do you want us to go just a little bit slower, be like more explained?
I think you guys know, I mean, you guys are so much better working one-on-one than we are because we're used to dealing with the whole class. So I think you guys are so used to working one-on-one, you can probably gauge right away where that student's at. I would think with your experience as a tutor. So I would think if a student sits down, you can tell if that student is proficient in saying, okay, I know it needs to be 6, you know, then you can teach them how to do 3 times 3 over 3, 2 over 2, you know. But if the student's like, oh, what, come down here, I don't know what you mean. You know, you could kind of tell where they are in their, I would just say, go with your gut in that case. And just like when students come to us for our office hours, if they want help, I kind of have to ask them a couple questions and say how far back do I need to go before I can answer their question. I would just say gauge it, you know. If they're totally lost and have no idea, then I would pull these out, you know. But if they know what a common denominator is and they just don't know how to maybe find the LCM, then you just start by teaching them how to find the LCM. So that's what I would
So don't default to these unless.
I would say see where they are. I mean, and you can have them on hand, obviously, you know. But I would say see where they are with them, you know, or if they say, oh, I don't want to use those, just teach me how to do it, but if they're not understanding this, then back it up and say, maybe we should use these for 1 or 2 problems. Because I think, I just think that's, I don't know about you, I think that's so powerful, saying I need 6 greens before I can add this together. Okay, I need these to be in terms of 6, not in terms of 1/2 and 2/3.
And Jennifer, I mean, that solidifies like what we know about brain learning and, you know, Janet Zadina always says, everyone except for the sight impaired is a visual learner. So whatever you believe about learning styles, everyone's a visual learner. And so I think that's what's going to really make it concrete for some students.
And you're an English person, right? So I mean, does that help you? You know,
Yeah,
being a
I think-
math person?
I think it creates more meaning to what we're actually doing with the numbers.
Okay, we'll try to do a division one really quick. I have division on another packet, so I'm going to hand it out. Division is only the Cuisinart, so while I'm handing this out, or while Ben hands it out, if you want to put the other stuff away, we're just going to use the Cuisinart for division.
Would you make sure everybody gets one?
I know.
Okay,
one for everybody, and we have the hands free for doing so. Put it on a chair here.
Amy,
Do we know which group or that they're using?
Queen and Rock. Now, when we teach division, like I said, we don't, like I was explaining before when I had that problem written on the board with the copies up, we definitely do not lead with the invert and multiply algorithm. Like that is very, very last after we've shown them all the conceptual stuff. And the thing is, we're not trying to hide that algorithm from them, you know, because they're going to need it later on when they get to rational expressions and they have to divide that and stuff, you know, but we want them to just really understand what it means to have a fraction divided by another fraction. So before we teach them that invert and multiply, we do a lot of conceptual stuff. And then the idea is that the algorithm evolves because of the conceptual stuff we did. They start to see patterns. Okay?
This is wonderful stuff, except it's using
All right.
Well, they're gonna just.
Okay. So let's go to.
No, you were talking
Did we just share one there? We'll start here. We'll just start on the first page. Okay. So orange plus brown is your one train. Did we already fill this out of the other one?
Yeah. 1/2, 1/3,
So
1/6.
dark green is a third,
Uh-huh,
light green is a 6,
yeah.
red was a 9, and then 118. Okay. So like I said, we've already done that. So when you do this activity with the students, the teachers can say, hey, remember we already did this, here's our values. So it says, use this technique in the table of values to answer the following question. So let's jump to a good one. Let's do the 2/3 divided by 1/9. Okay, so let's jump to that one. What is 2/3 divided by 1/9? Now notice the first thing we do is we ask them to restate the division problem as a question. So if I have 2/3 divided by 1/9, in other words, I want to know how many copies of 1/9 are in 2/3. So that's the first thing we want them to do. We just want them to know what are they being asked to find. How many copies of 1/9 are in 2/3? So I need my 2/3, right? So dark green. So I need 2 dark greens. And I want to know how many copies of 1/9 will fit in there. So reds. How many reds does it take to fill up the greens right there? So how many copies, so basically I'm saying how many copies of reds does it take to fill up these 2 greens? Oh, it takes 6. Okay, and again, that kind of blows their mind because they're like, huh, 6? I think it's 6 out of that. You know, because they always think fractions, things are getting smaller when you work with fractions. No, not if this is smaller than this, you're going to get a bigger answer. Okay, so how many copies of 1/9 are in 2/3? So there's 6. So jumping ahead, they would do a bunch of those. Now let's go to the next page. Right here. Okay, so it's the same problem.
Can you look at the 1/9 divided by 1/3?
Surely. Yeah, because that goes the opposite way. You're absolutely right. Okay, so what is 1/9 divided by 1/3? In other words, how many copies of 1/3? This is a good one because now we're going bigger into smaller. How many copies of 1/3 are in 1/9? So now the 1/9 was our red, and the 1/3 was the dark green. Okay, so you're asking, you're saying how many copies of? Well, they're like, well, the green's bigger than the red. The green doesn't fit into the red. So we need a portion of the green. So what portion of the green is equivalent to one of those reds? And so you say, oh, well, if it takes 3 reds to make a green, a third, a third, a third. So there's 1/3 of a copy of the green in the red. So the answer would be 1/3. So it's less than a whole.
I tell them to pretend the top block is the numerator and the bottom block's the denominator, so it's 1/.
Huh, that's good to know. What if they do it like this? But do you always tell them to like put one at the first, like, do you tell them to notice which one's on top and which one's on the
Well,
bottom?
I only tell them to use that method when it's less than a whole number.
Oh, okay, I see what you're saying.
Yeah.
So then they put the
It would
smaller
work
one on
either
top.
way, Yeah,
Yeah.
because a lot of them have a hard time looking at that and going, 1/3, how did you get that?
Yeah, because it's a third of a copy of the green and you fit into that red. Where it's kind of like, I don't know, if this is full of candy, and this is like an empty Pez container, how much of your candy could you fit in that? Oh, you can only fit a third of your candy, you can fit all the candy in there. Something like that. All right, so then, they go through these series of questions up here. I won't actually do them, but I'll just give you the idea. What is 6 red rods divided by 2 red rods? Oh, 3 red rods. Okay, what's 6 white rods divided by 2 white? Oh, 3. 6 purple divided by 2 purple. So the idea here is that it's always 3 no matter what color we use, as long as the colors are the same, okay? So then that gives them the idea of same color, same denominator, same denominator. You're probably wondering, why do they want a common denominator when they're dividing? Because that's how we start teaching them the concept of division. So right here with the 2/3 divided by the 1/9, it says problem rewritten with same type of numbers. So let's go back to modeling it first. So the 2/3 is 2 greens, right? And I want to know how many copies of 1/9 go into that. Well, I'm going to exchange my greens for reds so they can really see what's going on. So, again, the idea of equivalent fractions, I can replace the 2/3 with 6/9, okay? So I'm saying how many copies of 1/9 are in 2/3? Well, there's 1, 2, 3, 4, 5, 6. So we could see that there's 6 copies in there. So instead of saying how many copies, so probably rewritten with the same type of numbers. So I turn 2/3 into 1, 2, 3, 4, 5, 6/9 divided by 1/9. So the idea is to get them into the same color. So when it says same type numbers, again, we're leading to common denominators, 6/9 and 1/9, same colors, same type of numbers. Now, the equivalent problem would be, and the idea why we have them find a common denominator is, once you have the denominator the same, all you have to do is divide the numerator. It's 1 red into 6 reds. That's why they answer these questions up here. It doesn't matter what color they are, it's 1 into 6. So I don't care what the ninths are, as long as they're the same. I don't care if it's 6/4 divided by 1/4, 6/5 divided by 1/5, 6/9 divided by 1/9, it's 1 red into 6 red. So equivalent problem then would just be the 6 divided by 1. And then written in fraction form would be 6/1 or just 6. Okay, so the idea is if you get a common denominator, all you have to do is divide your numerators and then that's your answer. Okay, instead of flip and multiply. So that's what we start with. We have them get a common denominator for division, and then we say, oh, okay, well there's 1, how many copies of 1/9 are in 6/9? Well, there's 6 of them, because they're the same color now. I don't care about the denominator anymore now that they're the same. Okay, so if you have your students come in and like, oh, my teacher wanted me to get common denominator for division, and you're like, what? What's your teacher talking about? What are they talking about? That's why we do it. So then something like this, like, oh, let's make it ugly, like 7/15 divided by, I don't know, 3/8. You know, if I invert that and multiply, I'm not getting any nice numbers that are going to cancel out. So if I get a common denominator, 60, wait, I might use 1. So 15, 8 on 8. So that's 56 over 120 divided by 45 over 120. Then all I have to worry about is 56 divided by 45. And then the answer is 56/45. So, because now they're the same shape. Now they can imagine you got 100 and pizza cut into 120 pieces or whatever. You got 56 of them here, 45 of them here. How many times is 45 going to 56? So that's the idea. So that's why if you see them or hear them say they need a, the teacher showed them a common denominator for division. And then, like I said, the rule emerges out of that. They leave the module knowing the rule. right, Kim? They leave knowing, you know, when they're done with their 5 weeks, they're gonna know to invert and multiply. But we're hoping they'll understand where that comes from. So they understand why they get whole numbers and